Hi, thanks everyone for coming. Well, there's more people than I expect. I guess the topic of the talk really attracted a lot of people, and I hope doesn't disappoint you guys. All right, without further ado, let's start. My name is Yuzin Chua, my tutor is Yuzin. And yeah, let's start it. So we have four agenda to go on today. The first one is a background on this data. And the second one is how data is obfuscated. And the third one is some discovery that we found out from the data, we as an I. And the fourth is on serverless architecture, how this whole thing is done without having to spin up a server. So just a little thing before we start. So if you have a laptop, if you're lucky to be seated, so please take out your laptop and we'll do some hacking together. So a little bit background. Okay, has everybody heard of this app called Taxi.SG? No one? Okay, a few, like less than 5. That was launched back in 2005, I think, 2004, late 2004. And yeah, basically what it does is it tells you where the taxis are, and that's kind of it. You can flag a taxi using the app, but it doesn't really do anything except to set the thing over there. And I'm not sure which taxi driver are looking at this app while they're driving, but that's basically what the app does. And this is what the community is saying. Like, Straight Time saying that, Tech in Asia saying that. Yeah. If you look at the app rating, yeah, it's not really that good. So this is what people are posting about. I'm not going to read that. It's in Singlish. You can see that. All right, but for me, when I heard about the app, I downloaded it. Okay, it doesn't do anything much, but I was pretty excited when I first saw the app because, oh my God, a real-time taxi location API that's available for all of us. We can track taxis now in real time. So I was super excited. This is my daughter, by the way. Yeah, so let's do that. So if you have a laptop, take it out and just open up a terminal or something. And let's do this hunt. So if you open up the app, it has a few main API endpoints, but I'm going to cover 2 main API endpoints. The first one is this endpoint that ends with a CSV. So it tells you where you can see from the file name what it does. It basically tells you where the taxi stands are. So it fetch once when the app launches, so that you can mark on the map where the taxi stands are. But I'm not sure if you can mark on the map though, but it does load this data. This is my reaction, like, what? CSV is a data format? Okay. That's not that bad, but okay, but we have better data formats. Even XML is a better format, I think. Yeah. And the next endpoint that I discovered is this one, which is fetched every 30 seconds if you look at the app. Oh wait, let me go back to that screen. Okay, if you look at this screen, this is the actual URL that the app fetches, and this is one that's showing URL that you can do along as you follow this hack. So it's a bit.ly/taxi stands, and we'll give you the actual live CSV endpoint from the app itself. So the next endpoint is this. It's a zip file. It's a zip format. And this is the endpoint. So if you have a laptop, download it, bit.ly/taxi zip. The actual URL is this one, and I've shown you this one so that you guys can follow along, and you have to type the long address. It's fetched every 30 seconds so that I'm guessing so that the app would know that where the taxis are every 30 seconds, so it will update itself. So yeah, that's my reaction, like, what, zip? Like, okay, if you download the zip, who's download the zip file here? Yeah, try to unzip it.
I can't.
It's password protected. Like, what the hell? It's password protected. Right. Yeah. So, to cut the story short, so we found this is the password. Go ahead and unzip it. If you download it, go ahead and unzip it. It's NGC Taxi 2014. Go ahead and unzip it and open the file. Anybody here open the file? Right, just a tip of the day, zip encryption is very, very strong. You cannot do a reverse on that. You cannot, even if you brute force, you can only brute force, you cannot even do a reverse de-encryption of zip, so it's very strong. So if you want to store anything like secret, you can zip it and put a really long password, and you're safe. Okay, if you manage to unzip it now, you will realize that it's not even what you expect. It's binary. Like, text location in binary. So those my reaction, like, what is this doing? So if you can, the next thing you would do is you will try to examine the file. What is it all about? So you do a hex dump. You realize that you can kind of see that there's a bit of pattern in there, right? Okay, you can ignore the first row. This like the line numbering, but for in this case it will be the bit ordering. So you can kind of see that the pattern here, like all these stuff on 0D and all these 0, 0D, 0. So you can probably guess it. So how it works is that every 8 bytes is the position of the taxi at the time the zip file is generated. So if you do a hex dump, you can see that. And to add to the obfuscation, this is what it does. Instead of, we all know there is lat long, where all mapping API expects that lat long. It does a long lat, so you have to like switch it around a bit. So we're going to take the first 8 bytes as an example. So I'm going to, the next few slides I'm going to use as an example. So to add to the obfuscation, so this is the 4 byte. How do we translate that to a latitude address? So you first convert that to decimal, and the last byte you can ignore. It's usually 00. Then you take away 10, and then you add a 1 dot in front. This is the latitude. It's supposed to be public API for an app, but why do you obfuscate it? Like, if you want to protect it, you don't want it public. There's a better way to do that, but it's not really a good way. So yeah, you managed to figure it out. And for longitude, it's a similar way you would get the hex and translate the decimal and then take away 10. But you don't add a 1 dot in front because Singapore longitude is 100 and above. So you put a 1 in front and a dot after the first byte. So this is the lat long of this particular taxi that we are examining. So yeah. And we put it in Google Map. Yep. It tells us where we are at. This is a Marina Bay Cruise Center, and it's on the road. It's not in the sea or somewhere in the building. So yep, we did it. Right. So okay. So the next thing that we do after I got the data was why I was doing this is because I know the app is not really doing a good job, but I was really excited when we have a real-time taxi API data. I wanted to do a better visualization on this. I want to even do like something like Uber where you can actually see the taxi moving. But as I examine it more and more, I realized that I cannot do that for a couple of reasons. One, the data is only updated every 30 seconds. Second reason is that I don't have the ID of the taxi. It only gives you the lat long, so I cannot track a single taxi all over Singapore. So yeah. So the next thing I did is this visualization on. You can go ahead and play. I started collecting data from February 2016. Just going to do a short demo here. Okay, so this is the URL. And there are basically two tabs. So snapshots are all the, basically this app when it loads, it will load the first last 14 days. And you can see the data. The data is not really, it's not very consistent. So this graph is smoothed out over 5 minutes. If you do it every 30 seconds, like how we collect, it's actually very spiky. And even then, there's like a drop just 2 days ago. And then now I think for some reason, some of the, I'm not sure why the drop though. I think maybe a taxi company stopped changing, but dropped so much, so significant. And then now we're back up again. We're almost back up again. So yeah, and then the bottom of it is, shows the actual live location of taxi. It's only updated every 30 seconds. So if you check the live box here, yeah, it's updated every 30 seconds. You can kind of see it move. So you can kind of see where the hotspots are. Like this is Changi Airport. These are the CBD area. We're at somewhere around here. There you can see the hotspots are. And if you can click on the time and to see other snapshots. And the other thing is animation. If you select a day, it will then download the animation data. So this I pre-downloaded so that it wouldn't take too long. So it would then load the data for the day, and you can, instead of loading every 30 seconds, this only loads every 10 minutes so that it doesn't put too much strain on your data and also on your browser processing. So if you do play, you can kind of see where it moves at the time here. Just make it smaller. So you can kind of see where it shifts. So in the middle of the night, you can see where the hotspots are usually around Geylang area. Changi Airport is always hot. Geylang area, this is the jump site area. And as you get to morning rush hour, you can kind of see that you can expect that this area will get pretty hot soon. Yeah, so now it's like 8:30. And yeah, you can see it going up. 9 is starting to get pretty red over there. Yep. So yeah, you can play along the data, and you can skip to it and back. Yep. So just a little bit about the data, and yeah, back to the slides. So yeah, go ahead and play. And we discover a few things as we examine the data. We're going to share two things over here. Taxi surcharge does not seem to work, as we found out. Somebody got clap? No? We actually might need to increase it. What? Okay, Singapore taxi surcharge basically works this way. In the morning rush hour, you get 25%, and evening rush hour, you get 25%, and midnight, you get 50%, I guess, to incentivize people driving graveyard hours. But from the observation, you can see that the lowest points are actually during rush hours, 9 o'clock, 6 o'clock. And in the middle of the night, it's actually the highest. So you can see the area on the graph over here is actually the highest. And the lowest point are in rush hours. So it kind of like defeats the purpose of having, why having surcharge when, why all these taxi drivers are not coming up for surcharge? Why do we not like incentives? So I think we probably are not paying them enough to come out during rush hours to sit through the bad traffic. Not sure. So other fun random hotspots observation that we share, that we found, airport is always packed. Singapore Zoo, I never realized that it closes at midnight. So from that, you can see that the hotspot dispersed at midnight. And at graveyard hours, I found these two places, maybe there are any other places. And at this building, it is always packed. I have no idea why. If you Google this building, it doesn't do anything remotely to taxi. It's not a taxi service center or anything, but it's always packed, 24 hours. And but not just packed, not just parked, you can see the taxi are moving around a little bit as well. I'm not sure why. But yeah, maybe you can play around and can discover something interesting. So, yep. And the last thing I'm going to share, since it's a FOSS talk, so I'm going to share a bit on how we do this whole thing without having a server to maintain. I maintain a few servers during my day job, but I don't like maintaining servers. There I have to say that. And my quest now is to always have services that run without a server that we need to maintain. So how this works is we're using AWS Lambda. Has anybody used AWS Lambda? One, yeah, a few. Yep. This is a pretty cool technology where you just pay for the time that it spends to run, that it needs to run a function, and you don't even have to maintain a server. You don't have SSH access to it or anything at all. So basically the server side is run on AWS Lambda, and we are also serving a direct translation of the taxi, direct obfuscation of taxi data. So if you get to this endpoint over here, it's not grabbed through our DynamoDB database, but it's actually doing a direct translation of the LTA obfuscated API. So if you just get here, you can actually just write app without having database to just get direct endpoint from here. And also added a CORS header to it, so you can write app that doesn't run on an LTA domain. The original API doesn't have the CORS header, so you cannot actually write apps that fits directly to the API. And we realized that the data is updated every 30 seconds, so we have to update every 30 seconds. But Lambda has a time, in order for it to trigger itself, the smallest amount of time that they can do is only 1 minute. So that's a pretty sad thing, that I have to spin up a server to just fire an event every 30 seconds just to trigger this data collection, so that we can have as much data as we want as we analyze them. And visualization is basically just a single page app. It does not have, it connects directly to database, DynamoDB database with read-only access. And all parsing and everything is done in client side, so there's no need for a server side to do all that. And that's why it's pretty heavy on your browser. And yeah, that's all. Thank you. Any questions? Any questions, anyone?
So what language did you use for the map-based visualization?
Oh, it's basically Google Maps.
All right.
Yep. This is Google Map with a layer on top, so that the hotspot can shine through better. So you darken the background a bit.
How do you manage to get the password?
That's a good question. I didn't share that one. Yeah. So how we went about getting the password is, when I first got the app, I was so interested in trying to get the API. So naturally, the first thing that you would do on an app is you would then run a proxy server to see what endpoints it tries to make. So we found out the zip, and then it's unfortunate that it's password protected. So the next natural thing I did was to brute force the password. It was a CCT, it was like more than 10 characters, so it takes a long while to brute force. Tried it for a while, but not successful. And then I did not expect it to have such a small alphabet range, so I was including like symbols and all that, spaces and all the weird characters. So it takes a long time to even brute force 6 characters. So yeah, it was not possible. And the next thing that we do is to decompile the binary from the mobile app. So if you decompile it, you can kind of see where bits and pieces go, but the variable names and all that are gone. So you have to do a little bit of tracing to see where to discover certain things. Yeah. Basically, you can kind of see the source code, but there's no variable name, so you have to kind of figure it out yourself. Yeah, it takes a bit of time, but I was pretty happy that we managed to figure it out. Hope I don't break any rules there. Any other questions? Right.
What's the tool you use to step through the code?
Okay, the front end system using React. It's actually my first React project.
To find the password, what's the tool you use
To step through the code.
like,
Oh, okay.
No.
I'm not using any tool at all. Just decompile and just open up in a text editor.
Just like hex.
I didn't really do a step through. I didn't do a step through. Yeah, I was opening up a text editor and just trying to roughly get it. I realized there's a lot of arithmetic going on with the binary. Like, oh, what are they doing? Any other things?
I just wondered, since we probably thought about it as well, I mean, the obvious question is, what do you speculate is the reason for the obfuscation?
Yeah, I think that's a valid question. I don't really know, but I think probably how it went in us probably guessing is that, yeah, we want to build this app, and we need to make this data that we have, we need to open it out. But then maybe we don't want the public to have such a detailed data, so maybe obfuscate it. So maybe make it like a little bit harder for the public to get. So they have so many layers of obfuscation. I was so surprised. They put in binary and they jumble up, do some arithmetic, and then do a zip, and then put a password there, and like, wow, it's amazing that they go through. Yeah.
Did you ask them to allow access for the S string so that they'll ping your lambda directly?
That's a No, but I do ping LTA every since I started collecting data. So their sensors do go down every now and then. I'm not sure if you can see. I only load for 14 days, but their sensors do go down every now and then. Sometimes when the app is offline, I ping out to them, hey, your taxi app is offline. Can you make it up? Can you get it back up? They don't really respond to me, but I realized that after within say about half a day, the app will be up again. So they probably are saying, yeah, somebody's using the app. I have an alarm that whenever their system doesn't send in data, doesn't update, it will ping me. Maybe not because I want to monitor their uptime, but I want to monitor my my data collection so it doesn't go down. Yeah. All right. Any other questions? All right, cool. Thank you, everyone. Thanks for coming.